In this question, we're asked to find, we're given 3 points, A, B, and C, and we need to find out if the triangle that connecting these 3 points forms is equilateral, isosceles, or scalene. So just remembering that the definition of an equilateral triangle is that all the three sides are equal. So a stroke here is a particular size. They all have the same size. Isosceles, we have two sides which are the same, and then we have a third side which is different, and scalene, which is all three sides are different. So our 3 points, A, B, and C, you don't have to do this, but just for sake of illustration, we have our graph here. So we go for A, x coordinate 7, y coordinate -4. Here we are, here's A. B is x coordinate 3 up to y coordinate 7, here's B. And C is x coordinate -4, y coordinate 0, so sitting on the x-axis is C. And connecting that, I would suggest using a ruler. You must use a ruler. I don't have it on this program, unfortunately. So we want to know what sort of triangle this is, and we can do this using our distance formula here, which allows us to tell between 2 points the distance is the square of the difference in the x coordinate plus the square of the distance in the y coordinate, and taking the square root of all of that. So let's begin with our line AB, which is here, and we want to know what the distance of that line is. So here we have the square root, and we begin with B, which is our second point, AB, our second point, and the difference of the x coordinates, so is 3 minus 7, and we that's squared, plus the difference in the y coordinates, which is 7 minus -4. So here 3 is x1, is x2, and 7 is x1, the x coordinate of the first point, and here this is y2, the y coordinate of the second point, minus the y coordinate of the first point, -4, squared, and we take the square root of all that. So just doing the numbers here, 3 minus 7 is -4 squared, plus 7 minus -4, which is 7 plus 4, which is 11 squared, equals square root of any negative number squared is its positive becomes positive, and so -4 times -4 is positive 16, plus 11 squared. Now if you're not sure about these numbers, I'd suggest just going to your calculator, and here we have 11, and we go up to squared, 121. 121, and 121 plus 16, so add to that results, plus 16 gives us 137. So that side is square root of 137 units in long. So great. Here we have our first one, 137, square root of 137. Let's take another side. Let's go for BC. So the length of our line, BC, is the square root of the difference in the x coordinates. So C becomes the x coordinate of C becomes our x2, and that is -4, minus the x coordinate of B, which is 3, squared, plus the y coordinate of our second point C is 0, minus the y coordinate of our first point B, which is 7, squared, which is the square root of negative 4 minus 3 is negative 7 squared, plus negative 7 squared. Now, if you're not sure, again, just check it with your calculator. 7 squared is 49, and because it's the square of a negative number, it becomes positive, so it would become the square root of 49 plus 49, which is, let's add 49 to that again, 98. So the length BC is the square root of 98. So far we have two different sides. So this could either be, we know it's not equilateral anymore, it could either be isosceles or scalene. That depends entirely on the third side, which is AC. So applying that again, we're looking for the x-coordinate of our second point C, which is minus 4, minus the x-coordinate of our first point, 7, squared, plus the y-coordinate of our second point, C, which is 0, minus the y-coordinate of our first point, negative 4. Remember, it's helpful if you're substituting negative numbers to put it in brackets. That way you'll know that you subtracting a negative number becomes positive. So just looking at that, we have the square root, negative 4 minus 7 is negative 11 squared, plus 0 minus negative 4 is positive 4 squared. And remembering 11 squared is 121 and 4 squared is 16. And our answer is the square root of 137. These were both in units. We're not given a unit, so we just write units because it's a length. Okay, 137. So we know AB, 137, and AC are both the same length, and BC is different. So what we have an isosceles triangle, because we have two sides. So we just need to write our answer now here. The triangle is isosceles. Since AB equals AC, okay. So we know two equal sides, isosceles, and you're done.